Okay. The next question. Oh, actually, I'm going to just show you another way of doing that last question of getting at r. You could have used the laws of exponents. You were given, you're trying to figure out this thing at the top and show that it converges. But if you make this into let's see here, we make this into 3 squared times 3 to the minus k. And 3 squared is 9, so 4 times 9 is 36. But 3 to the minus k is really 3 to the minus 1 to the k power. So it's just another way. 3 to the minus 1 is really 1/3. And when you look at this formula, the number that's being put to the power, that's what r is. So r is a third. So this series must converge because 1/3 is less than 1 or greater than minus 1. That's the condition for convergence. Okay, that's just another way of doing it. I'm going to get rid of that stuff because I don't even want it. In fact, I don't want it here. The next question asks something else. They say, what if this whole sequence added up to 2 over 9? It wouldn't start at 1. It starts at a different place. And so they have this thing here. Ooh, I'll try to make it a little bit bigger. It's kind of hard to see here. But we have this formula. They're saying, what if this infinite sum came to 2 over 9? Well, um, what would k be in the bottom? It's not 1. It'll be some new number. They say find p, the new number that it would start at. Well, what you're having to do is you're having to think to get this to add up to 2 over 9. Now, the first number over here when we did it was a 12, right? That's the first term. Well, if 12 is the first term, if we keep adding numbers and get way bigger than 2 over 9, we need to start at some fraction. But where would that be? Where would that be? So we have to find the new first term. Well, here's the sum to infinity formula. They say it adds up to 2 over 9. I know that r is 1 over 3 for this sum, this series, but I'm going to try and figure out what a is. So a over 1 minus 1/3 we can put in for r, and we know that the whole sum is 2 over 9. If we solve 1 minus 2/3 is 2/3, we multiply both sides by 2/3. Hey, we've got part of the problem solved because we know we want this summation, but we want the first term to be 4 over 27. Well, if we use that formula, 4 times 3 to the 2 minus k, and we put in 4 over 27, that first term, and then we solve it, I think we're going to get our answer. Well, let's do that. 4 over 27 equals 4 times 3 to the 2 minus k. Let's just solve this. Divide both sides by 4. We get 1 over 27 equals 3 to the 2 minus k. But 1 over 27 is 3 to the minus 3. And you remember the whole thing with solving exponential equations is to get the base the same. Well, we've done that. So now we've got minus 3. This could only be true if minus 3 equals 2 minus k. So we add k and we add 3 to both sides and we get k equals 5. K equals 5. Well, that's the number that you need to start with. Um, we don't want to start the sigma notation with 1. If we start with k equals 5, which is, they said, p, what's the new value p? If we start with a 5, and then we put in the formula, and we go 2 minus p, and we start with 5, this infinite sum, the first term will be 4 over 27, and then we add up all the other terms, and it'll add to 2 over 9. It makes it work. So that was a little bit tricky, but that's it, because we had to find the first term of this infinite sum that went over 2 over 9, and then we had to use the formula and the first term to solve for the unknown number that we're going to start with. Okay, there, that fine. Okay, that's it. That was a bit of a tricky question. I hope this helped. Okay.